Leaving Cert Higher Level, Paper 2, Question 2, 2018 is a statistics question based on Z-scores. You're given this normal distribution or standard normal curve, and you're told the shaded area represents 67% of the data. Find Z1. So you have to go to your Z-score table and find the number that represents 67%. And this one works out evenly, 0.44. So 0.4 on the left of the Z-score table, and 0.04 when you go down that column you see 0.6700. So this is the Z-score. Z1 is equal to 0.44. A really straightforward introduction into this question. Part 2 of this question, you're told that there was a maths exam where Mary got 65% and the average or the mean was 70 and the standard deviation was 15. You can see straight away here, if Mary got 65 in this exam, she was a third of a standard deviation away from the average. And 68% in English, she was 4% away from 72, so she was 4/10, 40% away. So it looks like she's done better in maths here, even though the result was lower. Now there is a Z-score test we can do. It's X minus mu over sigma, where X is the test statistic, so we're testing 70, minus the average, sorry, we're testing 65, minus the average, 65 minus 70, over 15, which you can see that's that there, that's where that 5 over 15 is coming from, which is 1 over 3. And for English, we're testing, she got 68, we're testing it against an average of 72, and a standard deviation of 10, which is 4 over 10. Now let's have a look at where these lie on the standard distribution curve. Now, if these were positive values, and we can see here they're negative, they would be over this side. So they're the positive sides. The negative sides are over this side. So how far away from the center is each one? Well, if we take this as 0.33 or minus 0.33, that's approximately there. But 0.4 is more to the left than 0.33 because we're going this direction. So relative to the rest of the students in the class, you can see that Mary did better in maths. We could also use the Z-scores themselves, and if we look up 0.33, we're going to get 0.6293. And if we look up 0.4, we're going to get 0.6554. So let's look at the 0.4 in here. So what's this score representing? Well, it gives us always positive scores on the Z-score table. So this 0.6554 means that there's, let's approximate 35% in there. It's about 34.46, but let's approximate 35% in there. And 0.33, if we put it over here, and we look at this number, well, it's, let's say 63, there's 37% in there. So if we turn them around to the left, we can say that in this area here, Mary did better than 37% of the students. And if we turn this one around onto this side, we can say that Mary did better than 35% of the students in English. So clearly, she was better at maths in this case. So B part 2 in English, the top 15% were awarded an A. Find the least whole number marked that merited an A. So we go to the Z-score table again, and we find which one represents 85%. And we can see it's around here. It's 1.0, 0.03. and 0.04. Now we don't have to get the exact value in between these two. We can just round it. We can take the nearest value to 85%. But this is 8485. So that's 15 away. And 8508 here is only 8 away. And this one's 15 away. So we'll say 1.04 is the Z-score. And then we don't know what mark. We don't know the test statistic. We do know the average in English was 68. Sorry, the average in English was 72. So that should have been a 72 there. 72. So X minus 72 over the standard deviation in English, Just check again. It was 10 is equal to 1.04. So x minus 72 is equal to 10.4. X is equal to 82.4. And the least whole number would mean that the person would have to get 83% to get an A. The last part of this question, you were asked to use the empirical rule or otherwise to estimate the percentage of students who score between 52 and 82 in the English test. So if you know your empirical rule, this is a really simple question. 68% are within 1 standard deviation, 1 sigma. 95% are plus or minus 2 sigmas. And 99.7% are within plus or minus 3 standard deviations. So we do a little sketch here. What was the average in English? 72. Just double check. 72. So 72 is here. The standard deviation was 10 from here. So that means that up to this point, that's 82%, 1 standard deviation. So based on the rule of 68, 95, 99.7, you guys all know that 68 is plus or minus 1. So there's 34% in there and 34% in there. The difference between 68 and 95 is 27. So in these two guys, there's 13.5%. And I think that's all we need here, isn't it? 72, that gives us 82, 62, and 52. That was the question, so they worked out evenly. Now you could have used Z-scores here and found the answer that way, but we just add up these three numbers, 34, 34, and 13.5, so 68 plus 13.5 is equal to 81.5%. So that's an estimate of the percentage of students who score between 52 and 82.